Okay, some of the basic concepts that we have to understand in studying fluid mechanics are density, a specific volume, and a specific gravity. Okay, density is one of the basic, as what I mentioned a while ago. Density is always defined as a mass per unit volume. Density is defined as mass per unit volume, and the unit of density is kilogram per cubic meter, and the reciprocal of density is a specific volume, which is the specific volume is equal to the volume divided by the unit of mass. Okay, for gases, the density of gas, or of uh, gaseous materials, um, is heavily influenced by pressure. Okay, so that is why the density is directly proportional with the pressure and inversely proportional with the temperature. Okay, as what you can see here in the graph. Okay, so there's the density and the pressure. Okay, and pressure, as what I've said a while ago, is inversely proportional to the temperature. So when the temperature is increasing, the density is decreasing. Okay, so that's inverse proportionality. um, on the other hand, if the pressure will increase, the density is also increasing, so that is direct proportionality. Okay, for liquids and solids, essentially they are incompressible substances, and the variation of their density with pressure is usually negligible. Okay, density is heavily influenced by the change of temperature. So, for example, um, a 998 cubic a 998 kilogram per cubic millimeter at 20 degrees Celsius at 1 atmosphere will only increase its density, okay, into 1003 kilogram per cubic meter at the same temperature, but the atmosphere is increased into 100 atmosphere. So the change of density here is only 0.5%. Okay, so what about the temperature? If we are going to increase a 20 degrees Celsius water, okay, this is referring to water, into 75 degrees Celsius at 1 atmosphere, from 998 kilogram per cubic meter, it will decrease into 975 kilogram per cubic meter. Okay, so here 998 kilogram, this is kilogram per cubic meter. The same with the values here, that's kilogram per cubic meter. Okay, and for this change from 20 degrees Celsius to 75 degrees Celsius at 1 atmosphere, the change of density is about 2.3%. Okay, that is why the density of liquids and uh, solids also are heavily affected with the temperature. Okay, sometimes the density of a substance is given relative to the density of a well-known substance. That is what we call the specific gravity. Okay, so specific gravity is actually equal to the ratio of the density of the fluid and the density of the reference fluid. Usually what we're using here is water. Okay, the specific gravity is also known as relative density, and this is a dimensionless quantity. There's no unit for this. Okay, it is important to remember that substances with specific gravities less than 1 are lighter than water, and thus they would float on water if immiscible. Okay, so um, here in this table are some of the specific gravity or the relative density of some substances at 20 degrees Celsius at 1 atmospheric pressure. Okay, so water 1, blood at 37 degrees Celsius is 1.06, seawater 1.025, okay, for gasoline 0.68, and so on. Okay, now if we're going to look at the ratio of force acting in a given um, volume, that is what we mean by this specific weight or weight density. And the formula for weight density is actually gamma equals density times gravity times g. Okay, in our um, next video, we're going to work some of the problems using these quantities: density, specific volume, and specific gravity.